This is Unit 2A, examples 3, 4, and 5. Example 3 looks at the results of a Gallup poll. So take a minute and pause and read through the paragraph if you haven't already. It's important to note that the sample is a random sample, so we know that there will be less or no bias. And they're looking at 1,000 adults and 501 teens. If we look, the data is in two tables here. So we have the first table, a self-description of health. And we notice that the data is broken into the adult category and the teens category. And the self-description of health, they're giving ratings: excellent, good, just, fair, and poor. In this table, each adult or teen only chose one self-description. You can check to make sure the percentages add up to 100. The second table is boxes that they could check, so they might have checked more than one box. So you'll notice the counts can count more than one choice per person. And if you check the percents, they're going to be much over 100% because many people answered more than one choice. So our first step in problem solving is always to understand where our data is coming from. So we want to know what's the source of this data and when was it gathered. So the source is a Gallup poll, telephone interviews, and the data was gathered in April 2001 and May 2001. We next want to make sure we know who or what are the individuals described by this data. So in this case, the individuals are people, but individuals aren't limited to being people. You could be measuring some object in a survey. And so the adults are adults in the United States and teens in the United States. We don't know more about any specific region. We do know it was a random sample, so we assume that it would be randomly spread throughout the United States. What variables are being measured? The variables are these self-descriptors of health in the first table, and then the second table is things that people have done that are not good for their health. So next we want to know what are the values of each variable. So these are the answer choices the variable can take on. So in that top table, the values are the categories excellent, good, just, fair, and poor. Here in the bottom table, all these sentence choices are the values. So these are the sentences that people check whether or not they apply to them. So we see we've got I weigh more than I should, I don't get enough sleep, I drink alcohol, I don't watch my diet, I don't get regular exercise, I don't get regular checkups, I smoke cigarettes. So all these answer choices are values that a respondent could check off in the survey. So what do we think? Are these quantitative or categorical? Remember, quantitative variables have a meaningful average, and they're typically a number response. So in this case, these are categorical variables because people are checking the category or sentence that applies to them. What questions could we answer using this data? So I might ask the question, are more adults or teens in excellent health? I might want to compare one of the sentence answers across the two groups, like smoking cigarettes, drinking alcohol, not getting enough sleep. Anything that we see in the table could be used to compare the two groups. So we want to think about which set of data can be represented with a pie chart. So recall the pie chart is only going to work with data that can be summed to 100% because we need to contain 100% of the data in the circle. So if we check adults and teens in the self-description of health table, each column totals 100% because we've got only one answer choice. So each person only gives one response. So we could make a pie chart for self-description of health. The second table allowed for more than one checkbox for adults or teens. So this would be problematic to try to make a pie chart because the tally is more than 100%. So only the first table can be represented in a pie chart. If we wanted to draw a bar graph to compare adult and teen responses to things they have done that are not good for their health, should we use the counts in the table or translate the counts into percent? So recall that there were 1,000 adults in the survey and 501 teens in the survey. So because we're working with different size groups or different denominators in the fraction, we need to compare these as a fraction, a decimal, or a percent. So because the sample sizes are different, we should use the percent to compare the two groups. We will also commonly use fractions and decimals. When we talk about decimals, we talk about the proportion of the total included. Okay, example 4 gives ratings information about sedans from Consumer Reports magazine. And so this is a page published in that magazine in February 2008. So if we look at how this chart or table was set up, we see there's the make and model for cars. So for example, Nissan is a make of a car and the Altima is a model of the Nissan. We're told with a dot whether or not this car is reviewed in this issue of Consumer Reports. And then the cars are given an overall road test score. So if you look, each car has a bar here for road test score, and each bar has a numerical rating in here. And then the bars are also broken up into these categories, depending on how high their ratings are, ranging from poor to fair to good to very good and excellent. We've also got the price as tested for each car. And notice that the cars start off with affordable family sedans, and then the price categories go up until we get to the large sedans over in the second part of the table. And then the last rating here is predicted reliability. So there are these different circle shadings for predicted reliability. The key is in the upper right corner of the chart. So we see we've got excellent is a circle with the dot, very good is the top half of the circle, good, fair, and poor. So we're going to be using this data to analyze the chart and make some graphs. So again, our first step for problem solving is understanding the data. So what's the source of this data and when was it gathered? So this data came from Consumer Reports in February of 2008. Who or what are the individuals described by this data? So sedan cars are the individuals described by the data. Recall, often we talk about people as individuals in surveys, but it could be cars in this case or any other object or animal. What variables are being measured? So we're measuring road test score, price, and then also the predicted reliability. And then what are the units? So road test scores have both categories from poor to excellent and those numerical scores. Price is measured in dollars. And then the predicted reliability has these circle ratings of the different shading possibilities for the circles. So we want to think about, are these variables quantitative or categorical? So we can look at the units that they're measured in. And we see both types of variables are included in this table. Scores and predicted reliability are taking on these categorical values, fair, good, etc. Score, the predicted reliability score, also has a number associated with it. And then the price is definitely quantitative because that's only a number. So again, if we look back at the table, the overall road test score is the one with the number on it. Predicted reliability has the shadings of the circle, but no number for predicted reliability. So what questions could be answered using this data? So which sedans have good or higher predicted reliability? That might be something, if you're buying a car, you want to think about, which sedans fall into the good, very good, or excellent categories. And then which sedans are priced the lowest? That might be another concern if you're thinking about purchasing a car. Now we want to draw a bar graph. So we can choose any one of the categorical variables. I choose predicted reliability. So let's move over to StatCrunch and see how we can do a bar graph in StatCrunch. So in StatCrunch, I've typed in the variable predicted reliability, and to give your variable a name, you click up here at the top, and then you can type in the different values the variable can take on. And then I've counted the number of sedans. If you want to make your cells a little bit wider, you can click at the top and make it wider in StatCrunch. It works very similar to Excel, except it's got more statistics operations and functionality, but each entry goes into these individual cells, and we can see the variable names go in the rows of the top, in the top row, and then each column corresponds with a different variable, and then we've got the row numbers down the side. So I counted up the number of sedans. You can check to make sure that I got this right, the predicted reliability ratings. For example, I counted 3 sedans that were poor. So if you look back at the chart, you'll see the poor rating is a solid circle. So I went through and I counted 3 with a solid circle. So you can check my numbers and make sure they agree with your numbers. So I want to make a bar graph. So I'm going to go to graph, and the bar graph is called a bar plot. And then I've already got all of my sedans counted, so we'll say with summary. And it asks for the categories. So it wants to know, well, which variable is got the category. So that's my predicted reliability variable. So we select the predicted reliability variable that we named. If you don't give it a name, notice over here these say like variable 9 and variable 10. So it would just say variable 1 and 2. It's much nicer to give it a name so you can easily choose it from the pull-down menu. And then the counts are in the number of sedans. We'll leave the type as frequency and we'll let it value by ascending for now. You can choose a different color scheme if you want. I'm going to leave mine on the basic 7 colors. And let's label our x-axis as predicted reliability. Let's label our y-axis as number of sedans. And let's give a title, Consumer Reports, February 2008. And if we click compute, we see StatCrunch makes a chart for us. And if we want to make our chart a little bit wider, we can drag on the corners. You might notice it is going by the different categories as sorted by StatCrunch. If you want to edit that, we can go Options, Edit. And when it says Order by Value Ascending, you could choose Order by Worksheet. And see how that leaves that in the order that we had typed it in. And again, you can make your graph bigger. So if we look here, we see the highest amount is the very good predicted reliability rating. If you hover your mouse over, you can see it tells you that's got a frequency of 14. Good has a frequency of 9. If we wanted to shift this to a percent, instead of just the count out of the total, we can change this to percent here and compute and see how it gives us the percent values, and we can hover over and it tells us, oh, predicted reliability good is 26.47%. You might have noticed if we go back into options, one of the other options was called relative frequency. And so if you do compute and you hover over, relative frequency is just taking the percent and making it a decimal, or what we sometimes call the proportion value. And then notice the scale for relative frequency is from 0 to 0.4. If you go back and change it back to a percent, you'll see it was going from 0 to 40%, with the very good category a little above 40% there. Okay, I'm going to go edit my options and put this back to just a frequency count so that my bar chart tops off at 14 for the very good count. Okay, so take a minute and pause and recreate a sketch of this on your packet page. The question at the bottom of the page asks, why is the bar graph a representation of the distribution of the variable? So recall, a distribution shows us the possible values and then also how often or the frequency the variable takes on these values. So because we can see down here along the x-axis all of the predicted reliability categories, and the y-axis tells us how often or the count that the categories take on. Okay, so in that example, we were graphing categorical variables. So now we're going to think about, how do we graph quantitative variables? A graph that shows a description of a quantitative variable tells us at a glance what value the variable takes on and then how often it takes those values. So we're going to make what's called a histogram. So in a histogram, you will not see the names of the individuals listed, but you will be able to determine at a glance the counts or percentage of individuals within each range of variable values. So recall, quantitative data is numerical data, so the histogram is going to sort the numerical data. And typically the horizontal axis shows the variable values in the histogram. We'll also see a stem plot where each entry is going to represent one individual. So we're asked to draw a histogram of the distribution of prices for the sedans. So if we come back to StatCrunch, we can exit out of here. And you can see I typed the prices of sedans in the third variable column, so you can type those values in, or if you go into the Math34 Summer folder in StatCrunch and join it, you can get this file in there. So we're going to go to Graph, and now we're going to choose Histogram for quantitative data. And it asks us to select the column. And notice it's not giving predicted reliability as a choice. It's only giving us quantitative choices. So in this case, we choose prices of sedans. And then just go ahead and hit compute without doing any of the grouping or frequency or adjusting the bin. And let's look at what the frequency is doing here and what our histogram is doing. So notice the y-axis of the histogram is always counting frequency. So what they've done is they've broken the sedans into bins. So if we look, here's $20,000 and here's the price $25,000. So it looks like each bin is $2,000 wide. So in this first bin, they're saying from $20,000 to $22,000, or probably $21,999. There are 9 sedans. Notice where it says price of sedans, it's got that close bracket by the $20,000. That means $20,000 is included. And then $22,000, notice over here there it has the open parentheses. That means that it only goes up to $21,999.99. If you come to the next column, see how it's got the square bracket for the 22,000? That means 22,000 is included in this next column up. And the 24,000 wouldn't be included. That's the end of this histogram. It would bump up to the next value. So you might say, well, I want to look at it counting by 1,000s in what we call the bins. So you can go to Options, Edit, and bin width, we could change it to be 1,000 and click Compute. And see what's happening here in our graph is now we've got 20,000 to 21,000, 22 up to 22,000 in the next bin, right? So each bin is counting by 1,000. We see here there was no cars between 24,000 and 25,000 in our price list. You could adjust the bins to count by 5,000s if you wanted, and we can see how that adjusts. So now we're venturing into what we call skyscrapers, which we want to avoid, where we've got too much data in one bin. If you went and edited and made the bins be maybe 10,000, you'd see we'd definitely be in skyscraper mode here, where we've got too much data in one bin where we can't really see much of a difference between the two bars. So when we say we want to avoid skyscrapers, this is a skyscraper situation. Similarly, we want to avoid what we call pancakes. So let's look at what happens if we make the cars count by 200s. So if we look at this, see how the data is pretty far spread out, and we see, you know, the frequencies only go up to categories with 3 cars. If we edited it and counted by $100 groups, we'd see even more of what we call pancakes, right? So see how we just get flat graphs with a bar at every place there's a car. So this is to be avoided. So I think my preferred bin size here was 2,000. So I'm going to leave it at 2,000. Okay, so you could take a minute and pause the video and make a sketch of this histogram on your paper. Make sure you sketch on your paper that you are labeling the x-axis and then all of the values here, as well as make sure you're labeling the y-axis and including that the y-axis is counting frequency. Okay, we're asked to describe the distribution of the prices. So we said there's a peak at the low end of prices and then a peak in the middle of the range of prices. So we can see there's a peak right here. You could say specifically the peak is between 26,000 to 28,000. We see there are not as many cars priced above $32,000. So this is a two-peak graph, or we sometimes call it a bimodal graph when it's got two peaks, bimodal, two peaks in here. So now we're asked to draw a stem plot of the distribution of the prices. And we've got a tip: you may need to round or truncate the data to avoid the pancakes and skyscrapers. You may also need to split the stems. So we'll close this out and go into graph, and stem plot is sometimes called stem and leaf plot. So in StatCrunch it's labeled as stem and leaf. And again, we're choosing prices. And then we've got to choose a leaf unit. So the leaf unit is going to tell us what values are counted in the right side of the stem and leaf plot, the leaf. So I'm going to put it at 1000 and compute, and let's see what we get here. So what this is doing is making us a chart of 2 here being 20,000, and the leaf are counting 1,000s. So the 2 and the 0 is a car that was rounded to cost 20,000. The 2 and the 0 over here is another car that got rounded to 20,000. Then we have a car that was rounded to 21,000. Notice, since we have a lot of data, they're putting the 20,000 through 24,000 in the top. And then they're doing another row for the 2s for 25,000 to 29,000. So in the stem and leaf plot, each value in here counts for a different car. And stem and leaf plots are easy to draw by hand once you decide on your leaf unit. And then you go ahead and can go down the list and make your labels in there. So we see it goes all the way up to 34,000. This is looking a little skyscraper-y to me, so I'm going to go edit and change my leaf unit to be 100s and see if I can see the shape of the distribution a little bit better. And I like this because imagine rotating this on your paper. It looks a lot like the histogram, right? Sideways, here's my peak for the lower values, and then here's my next peak for the mid-range values, and here's showing me just a few cars, just 1, 2, 3 cars that are more than $32,000 here. Or one car is $32,000, so just 2 cars are more than $32,000. So go ahead and sketch this stem and leaf plot with the leaf unit is 100 on your paper, and then take a minute and compare it to the histogram, and you can pause to draw the stem plot. Okay, we want to compare and contrast the two graphs. So we notice that stem plots and histograms both show the distribution of the data. In fact, if your leaf unit matches the bins of your histogram, when you rotate, they'll look just the same. Stem plots can be faster to draw by hand. That's one advantage to them. With stem plots, you do have to consider the leaf unit, and similarly with histograms, you have to consider the bin width. Okay, so in the group problems, you're going to practice drawing some of these, and you can take pictures with your cell phone and share those in the group work, or make your graphs in StatCrunch, and you can do screenshots and share those pictures in there.